Okay, let's look at one more example of factoring a binomial. This one, we've got two terms. Okay, we've got a cubed value of a cubed variable, and then we've got this floating constant here. So clearly nothing that they have in common. 8 and 125, there's no common factor there. So we can't pull out a greatest common factor. But what we can look for is, are these both perfect cubes? Is it possible to produce 8x cubed by doing something times something times something? Now, obviously, we can use an x in each one of those factors, right? But can I produce x by multiplying the same number by itself 3 times? And yes, 8 is 2 cubed. Okay, so we have 2x times 2x times 2x. That's going to produce 8x cubed. And 125 is 5 times 5 times 5. Now, if we're going to be able to use the sum of cubes in this problem, these numbers have to be the same. That's what makes this cubed, right? 5 times 5 times 5 is 5 cubed. Now, in a previous video, we wrote down, what this format looks like for the difference of cubes. The sum of cubes looks like this. I'm going to write that one more time here. So if you have, that's an A. Let's call that an A cubed plus B cubed. We're going to be able to factor that according to this format. A plus B in a binomial. Then we've got A squared minus AB plus B squared. Okay. Now, what I said before is, in a previous video, this 8x cubed is something times something times something, right? And then the 125 is that same number 5 times 5 times 5. And if you look at the way that the sum of cubes breaks down, whatever is being cubed here, this is really A times A times A. And then over here, we have a spot for 3 A's. This is really B times B times B, right? B cubed is B times B times B. And we have a spot for 3 B's here. So this is it's kind of a cheat code for how this whole thing breaks down. But if you can express the sum of cubes as the same thing being multiplied 3 times here, and then something else, but the same number being multiplied 3 times here, then all I have to do is fill in a format that looks like this for these pieces. So this is really, okay, we're going to have our binomial, and then we're going to have our trinomial. We've got 2x goes here, right? Then we've got 2x goes here. Now this one's a little weird because that 2x is being squared. Got to be careful with that. Okay, and then we have another spot for the 2x that we're going to put here. Okay, and then for the other part, for the b part where we have the second piece of the binomial, whatever's being multiplied 3 times here goes in for those b's. So I've got a plus b here, like that. I'm going to put my next b next to the a here. I'm going to put parentheses around it because those are being multiplied. And then that last b goes here, that last 5. Okay, like so. Now, we've got a little cleaning up to do with this. Okay, not in the binomial. The binomial is fine. So we've got 2x plus 5. Okay, but here this is 2x squared. And remember, this is really the same as 2x times 2x, which is 4x squared. There's a minus sign here, so I'll put a minus sign here. 2x times 5 is 10x. And then here we've got plus 5 squared. 5 squared is 25. So here is our factored form for this sum of cubes. So 8, I'll write this out, 8x cubed plus 125 can be factored to look like this. Again, all we're doing is expressing each of these cubes as this product of the same factor. Then we're taking each factor here and putting it in place here for the a's, and then for the second part of the binomial, each one of these 5s goes in for the b. When we plug it down here into this quadratic, or this, this trinomial part, we got to do a little work, because when something like this is squared, you don't want to make the mistake of calling this just 2x squared. Okay, we are squaring whatever we're putting in this place. So since we're putting a 2x, again, this is really 2x times 2x in that space, right? Which is 4x squared. And here we have to multiply these, and then we got to square this. So be careful when you're simplifying that next piece, okay?